Hi, everyone. My name is Cullen Sorrels. I'm a solutions engineer on the Data Clean Rooms team here at Snowflake. The purpose of this video is to walk through the Freeform SQL workflow in Snowflake Data Clean Rooms. The Freeform SQL workflow enables collaborators with the appropriate role to run freeform queries on datasets within a configured clean room using any accessible environment, such as Snowsite or the Snowflake API. These datasets function as standard read-only views, queryable via SQL, Python, or other supported Snowflake languages. Once a provider enables the Freeform SQL workflow for a dataset in the clean room, consumers can query that dataset against any other dataset they have access to in Snowflake. This workflow offers the flexibility to work directly from Snowsite or Snowflake-supported environment that technical team members are comfortable with, rather than leveraging the Cleanroom web app. Now that you have some background on the workflow, let's review how to implement it. In our documentation for Snowflake Data Clean Rooms, we offer an example script that can be leveraged as you explore the Freeform SQL workflow. It's really just meant to be a get started script for our customers to use as they explore Freeform. So what I'll do is copy this, and in Snowsite on my provider account, I've pasted a version of this, cleaned up a little bit just so that it's easier to read. And this is what we will leverage as we explore the workflow for Freeform SQL today. Now, when it comes to Freeform SQL, you can link any supported Snowflake object to your clean room, just like in the standard API workflow. However, since your consumers will be able to freely query this object or view, it's important to consider how to protect your data. And one of the best ways to do that is through the use of table policies. Today, we'll walk through aggregation, projection, and masking policies. So let's get started. First things first, I'm going to make sure that I am using a role, such as account admin, that has the ability to create new objects in my Snowflake account. Next, I'm going to create a new database called Freeform to use for the purposes of this demo. And in that database, I'm going to create a few different tables. We'll start with a table that has an aggregation policy constraint applied to it. So here I'm just creating a new table called ag constrained table in my new database. And I'm populating it with data from the Samuha sample database customers table. Within this Freeform database, I am now going to create an aggregation policy. And what this does is it constrains the result set of the query to ensure that it must meet a minimum size or threshold. So an aggregation policy is a schema level object that controls what type of query can access data from a table or view. When an aggregation policy is applied to a table, queries against that table must aggregate data into groups of a minimum size, in this case 100 records, in order to return results, thereby preventing a query from returning information about an individual record, which is what we do not want in this workflow. So I have my aggregation policy created here. The minimum record count or group size is 100 records. Now I'm going to apply this aggregation policy to my table. So I'll alter my Freeform public ag constraint table. I'm going to set the aggregation policy. And now if we query this table, trying to select a star, so all records from this table, we can see that an aggregation policy violation occurred. So in order to actually query this table, we must perform some sort of aggregate function. So I will test out a different query that has an aggregation function, and we can see that we'll get a record count back, right? So we're able to adhere to the aggregation constraint and query the table. Continuing on with other policies that we can apply. Next, we'll look at projection policies. So controlling what fields are able to be projected in the select statement of a query. If we have certain fields that we would like to ensure our consumers cannot include in their query once we make this available, then a projection policy could be a good option to add. Similar to the aggregation policy, I'm going to create a new table in our Freeform database. And on this table, I'm going to create a projection policy. This projection policy is saying that the projection constraint is set to allow equal to false. And then in this next line here, we're going to determine what field we want to apply that projection policy to. So on line 47 here, I'm actually calling out the hashed email field. So we do not want our consumers to be able to query the hashed email or pull the hashed email back in their result set as they query this table. So once I have that projection policy applied, here I'll test out the projection policy, and you can see that as I tried to use a select star, so to pull all of the fields from the table, I got an error saying that hash email was attempted to be queried, but needs to be removed from the list of projected columns in my query because it's restricted by this projection policy. So if I were to submit another query that maybe just pulled hash phone or another field that does not have a projection policy tied to it, we can see that we're able to get results. Moving on to the last policy that we'll cover today, we're going to look at creating a table with a masking policy. So just the same as we did with our previous two tables for projection and aggregation policies, we'll create a new table here in our Freeform database that we're going to apply a masking policy to. Snowflake masking policies are a column level security feature that are designed to protect sensitive data by dynamically transforming or obfuscating specific fields based on user roles or other conditions. This ensures that unauthorized users only see the masked or anonymized data, while authorized users or roles can access the original unmasked values. In this case, we're going to create a masking policy here, and when the current role is account admin or Smuha app role, then we will return the field value. Otherwise, we will mask the data with a series of asterisks here. And now we're going to apply that masking policy. So on line 70 here, we're going to alter the table we created, calling out the hashed email field, and we're going to set that masking policy to that field. So if we were to query the table right now as the account admin role, we can see that all of our data is returned. We're able to view the field values for hashed email. But if I were to switch to another role from outside of account admin or Simua app role, so let's say the public role, and then query that table again, we can see that our hash email field is obfuscated, so it's masked. So that field value is not available since I'm using a role that is not permitted to view the field value. Now that we've covered data preparation from the provider perspective and the various policies that could be used to protect your data, we'll get into the actual clean room workflow. So first things first, we're going to register the Freeform database that we created that houses the tables with various policies applied, just as we would any new database that we'd like to link or use objects from in the clean room. Once we do that, we'll get into the standard clean room setup here. So I'm going to set some session context variables here to ensure I'm using the Smooth app role. And then I'm going to call out a particular warehouse I'd like to use, which is the app warehouse. Next, some additional session variables. So one, the clean room name, which you may be familiar with. It's used in our standard API workflow today. And then for simplicity's sake, I am going to set a consumer locator and data sharing identifier variable for the consumer that I want to ultimately share the clean room with. The next two steps are similar and used in our standard API workflow today as well. So our distribution will be set to internal in this case because I'm going to share this clean room with a Snowflake account that is a part of the same org as my provider account. If I wanted to share externally, I would need to flip this over to external. The release directive here, again, is part of the workflow today. And we're going to have that set, as always, to version 1 and patch 0. Finally, we're going to link our data sets. So there's 3 tables we created with the various policies applied to the clean room. So those 3 calls are used today in the API workflow for Snowflake Data Clean Rooms, and nothing changes there. The next 2 steps are specific to the Freeform SQL workflow. The first is to enable Freeform SQL for this particular clean room and for a particular consumer. So this call right here on line 143 does just that. We're going to enable workflows for consumers for this clean room, specifying the Freeform SQL workflow and the consumer for which we want to enable that workflow. Once that's complete, then now we need to enable relevant tables or views for Freeform SQL. So again, a newer call that is not part of the standard API setup today is to enable data sets for workflow. Here we're going to pass in our clean room name, the workflow that we'd like to enable them for, which again is Freeform SQL, and then the list here, the array of data sets. So our tables that we've created with various policies applied. Once we're done with that, we'll add our consumer to the clean room in the standard way by calling add consumers here, passing a clean room name, the consumer locator variable that I created earlier, and the data sharing identifier variable I created earlier. And then finally, we're ready to create or update our clean room listing. So once we call this, our clean room will be shared with our consumer account and available for them to install. So now that our clean room with the Freeform SQL workflow has been created and shared to the consumer, we'll walk through the experience on the consumer side. So first things first here, we're going to set some session context just as we did before. To ensure we're using the Samuha app role, and we're going to just specify our app warehouse here. Next, we're going to set some session variables. So first, the clean room name variable, and then second, the provider locator. And really, the provider locator is going to be used mainly for the install of the clean room on the consumer account. So we'll go ahead and do that here, line 21. We're going to install the clean room that has been shared to us by the provider. Once installed, the first thing to check on the consumer side as you get ready to query are what data sets are available from the provider. And specifically the Freeform SQL views that were created when the provider enabled the Freeform SQL workflow. So running this call, we can see all 3 tables that we created on the provider account: the masked table, aggregation constraint table, and projection constraint table are all available. And in order to query these, we will take the view name produced by this get provider Freeform SQL views call and use that in our queries. Now, one thing we didn't go through is linking data sets as a consumer, which is typically part of the clean room workflow. You can do that as a consumer, but with the Freeform SQL workflow, if you recall at the very beginning of the series, with this workflow, you do not need to link your data sets as a consumer. So you are able to freely query provider data sets against your consumer data that lives in Snowflake without having to link it. So anything that you as the consumer have access to in Snowflake, you're able to bring in and use in queries for this particular clean room workflow. And we'll explore this shortly. Now that we know the view names of the various provider data sets that have been enabled for Freeform, we can start querying the data sets. So first, let's start with a query against the aggregation constraint table. And as you can see, I'm not utilizing any aggregation functions or performing any aggregation at all in my query. So this here is a test to confirm that the aggregation policy is in fact working and applied as the consumer looks to query this particular data set. Now, in order to successfully query the data set, again, there must be some aggregation used. So if we were to simply add age band here and group on that, performing a count of hashed email, we can see that we are able to get results returned. So the provider data is protected at a row level, but the consumer is still able to freely execute various analyses against that data set as long as aggregation is used. Next, we'll look at the projection constraint table. Again, if we try to select star or all records from this table, we'll see that we're in violation of the projection policy that's been applied. So in order to query this table, we must remove hashed email from that select statement. So if we try another query here with hashed email excluded, we can see that we're able to return any of the fields from the table that were not included in the projection policy. Finally, we'll look at the masking constraint table. If you recall, we had a masking policy applied to the hashed email field, so we wanted to protect consumers from being able to see the value for the hashed email. And we can see with a simple query here that that policy has in fact been applied and carried out to the other side of the clean room on the consumer side. Now, as I mentioned earlier, as a consumer, you do not have to link your data sets to your clean room formally. You can include any data sets outside of the clean room that you have access to in your queries. So we'll look at an example here of that. I am querying the provider data set with the aggregation constrained, the aggregation policy included, and I'm interjoining that to a table on my consumer account that has not been linked to the clean room. This demo customers table. So we're joining on hash email here. And since I am aggregating, so grouping on age band, doing a count of the provider hashed email, I'm able to get results returned here. So I can see by each age band, how many hash emails match between our two data sets. The last piece I wanted to explore with you was the ability to utilize CTEs or other familiar query constructs that you may use today outside of Snowflake Data Clean Rooms. With the Freeform SQL workflow, these are available to you just the same as they are outside. So here, as an example, we have an initial CTE where we're taking a subset of the provider data, filtered down to only females, and we are going to join that to our customers table that has not been linked to the clean room on hashed email. And what we'll get here is a result set that includes a count of matched hash emails or customers between our table and the provider table, grouped by our customer's loyalty status from the consumer side, and the income bracket from the provider data set. So just another example of the flexibility that Freeform SQL offers when it comes to executing analyses and exploring how your data matches up with your provider data. Now I'd like to talk about some best practices to ensure your collaboration is a successful one. As the provider, when you're thinking about bringing data into the clean room, a consideration you might have is maybe to create a view or a table with only a subset of the fields that are necessary from your source table, rather than bringing the entire source table in and then applying policies after the fact. So if we look at this example here, I'm creating a new view from my source table here, the demo customers table, and I'm only including these three fields. So any other fields from that table would not be available once I link this view to the clean room. So it's just an additional consideration around how to only enable the data that's necessary for your consumer in the clean room. Additionally, and I know we covered this earlier in the video, but really stress testing these tables after policies are applied. So in this case, looking at the table we created with the projection policy, executing a few queries against the table to ensure that you are getting this message, letting you know that the projection policy has been violated, and the field is returned that the projection policy is applied to. So testing anything that you think should be in violation of that projection policy, utilizing any of those protected fields, and then ultimately, some simple queries that should succeed against that table with the projection policy. Finally, data standardization and prep. So ahead of your collaboration, working with your partner to ensure that the same hashing algorithm is used on join fields and the syntax is the same. So whether it's uppercase, lowercase, spaces are trimmed, whether you need to use a SHA-256 hashing algorithm, all of these are important considerations ahead of the collaboration so that you don't have to come back and make adjustments down the road. An example of this would be, as the consumer here, I have a table and my provider and I did not align on the data prep for the join field that we're using. So mine is lowercase, while theirs is either uppercase or in another syntax or format. So when I go to execute a query, joining their data set to mine on HashGmail, you can see that we don't get any results. And this could be avoided if there was some collaboration ahead of time and alignment between the two parties on data prep, standardization, and formatting. Finally, I'd like to cover a few troubleshooting areas for common issues that our customers run into when utilizing the Freeform SQL workflow in Snowflake Data Clean Rooms. The first is using a window function such as max, min, or row number against a table that has an aggregation policy applied to it. A lot of customers are using Freeform to execute a last touch attribution or other analysis related to timestamps. So getting the max or min, the first touch or last touch date related to some impressions. If we look at the documentation for aggregation policies in Snowflake, under the limitations section, you can see that window functions are not allowed in queries against aggregation constrained tables or views. So with that being said, if you look at an example of attempting to use a window function, such as row number, against a table that has an aggregation policy applied, you can see that you run into an issue with that aggregation policy and that window functions are not supported. So here you have a few options. One would be to work with your collaborator to understand if it's possible to add a field corresponding to the first or last timestamp that's needed for the analysis. The other is to get creative with your query. So use time boxing or some filtering in your where clause in order to grab the timestamp that you need. So looking at an example of that here, I have a series of CTEs against an aggregation constrained table that has impression log data. And my goal is to ultimately produce a funnel of impressions, clicks, and ultimately conversions using that data. So here, instead of using a min like I attempted to in that first query, I am taking the CTE of join data, joining it to itself on our join field, which is HashGmail. And in my where clause, I am time boxing this. So where the first set of join data has a timestamp less than or equal to the second set of the same join data. And I'm creating a flag here so that as soon as there's a record that is not less than or equal to the next record, we know that if there's a sum equal to 1, that is our last touch. So point being, there are ways around this if your collaborator is not willing to include a timestamp or an additional field for you. And you can get creative with your querying in order to complete your analysis. The second thing I wanted to touch on was access to objects in Snowflake. So we mentioned at the top of the video that with Freeform SQL, you're able to query the provider data sets that are shared and join to any data sets that you have access to in Snowflake. Now, there could be a situation where you go to execute a query and you see that the particular data set from your account as a consumer does not exist or is not authorized. So in this case, this requires reaching out to your account admin or someone that has the appropriate role to permission access to this data set so that you're able to successfully query it. These are just a few common issues that we see customers run into as they explore this workflow. If you run into any other issues, please reach out to your Snowflake team, and we are always happy to help. One of the things I really enjoy about the Freeform SQL workflow is the immediate results that you get, right? So there's not a lot of wait time as you're executing queries. It is very similar to writing queries and executing analyses in Snowflake today. So for the technical team members that are comfortable in Snowsight, this is a great option to explore a clean room workflow. It gives you a lot of flexibility in terms of the analyses that you can execute. So I appreciate your time and attention, and this concludes the quick start on the Data Clean Rooms Freeform SQL workflow. Thank you.